my dear children. Happy morning. The last class we discussed about what are the various steps involved in the chemical method for the preparation of colloids. Today our learning objectives after the preparation of colloids. Next we have to purify the colloids. Am I right? The colloidal solution having number of electrolytes. Mostly the electrolytes we can be examined. I am giving the example in sodium chloride electrolyte. Okay, one of the electrolyte may be a positive charge or maybe the negative charge. So we should remove the electrolytes from the colloidal solution by the means of the purification. Okay, purification of. So today our learning objective is to learn about the purification of colloids. Purification. Okay, here we have three important purification. One is about the dialysis. Another one is the electrodialysis. The third one is the filtration, ultrafiltration. Okay, filtration. About the dialysis is all of you know about the dialysis. Here we are taking one of the colloidal solution in a bag, in one of the big bag. Okay, big bag. Colloidal solution is taken in one of the big bag that we have called as a semi-permeable membrane, a cellophane sheet. Okay, anyhow, one of the semi-permeable membrane, we are taking the colloid inside and immersed into one of the tank containing water. Okay, the water is a running water. We are applying a running water. So the semi-permeable membrane having a number of minute holes is there. Number of pores. Okay, otherwise called number of minute holes is there. Okay. Here, due to the minute holes, the colloidal solution having a number of electrolytes, it will be easily passed through the holes. But the colloidal solution never go. Okay, colloidal cannot be migrate through the holes. So, by this methods, we can be easily remove the electrolyte. Okay, by the dialysis experiment. Okay. The second step is about the electrodialysis. Dialysis means it is almost a slow step process. The electrodialysis means it is a high speed process by applying a current. We are taking some two electrodes. One is a cathode and another one is anode. Cathode is a negative charge and anode is a positive charge. Am I right? And also we are taking two membrane. One is about the cathode cation transfer membrane, and then near the anode we are taking anion transfer membrane. In between the gaps we are adding the colloidal solution. So the colloidal solution having number of ions, that means electrolyte. This electrolyte is attracted by the opposite electrodes. For example, sodium plus. Sodium plus is attracted by the cathode and chloride minus ion is attracted by the anode, because cathode is a negative and anode is a positive. Okay, it's very important about this electrodialysis. So today assignment is also same question I am giving. Okay, try to learn this question. Okay, so today assignment, this question, try to learn this question: dialysis, electrodialysis, and also ultrafiltration. The three questions are important, and about the ultrafiltration also very important question. Try to learn this question. So first one is about the dialysis. I am giving a small diagram for the dialysis and ultrafiltration. This is only for your understanding, not for the examination point of view. Okay, only for your understanding. Okay, so try to draw the diagram near the textbook of that particular question. Please, all of you take the note. We can write the question. Okay, about the dialysis. Today our learning objectives to learn about the purifications of colloids. Okay, dear children, yesterday we discussed about the condensation method. What are the various methods for the condensation? That is about the oxidation, reduction, hydrolysis, double decomposition and decomposition. Am I right? So I hope you maybe learned that question. So anyhow, today our learning objectives. How can you purify the colloids? Here, that means the colloidal solutions, due to their different methods for preparation, may contain certain impurities. Okay, certain impurities having, as per the preparation. That means by the preparation means one is about that dispersion methods. We prepared the colloids. That is a mechanical dispersion method. Am I right? Then about the electro dispersion method, ultrasonic dispersion and peptidation, and also the condensation methods of oxidation, reduction, hydrolysis, double decomposition, decomposition, and also by the exchange of solvent. These are about the preparation process. Am I right? Anyhow, the preparation having certain impurities. Suppose if we are not remove these impurities, that impurities may be destabilized and precipitate the colloidal solution. That's the meaning. Okay. Suppose if you are not purify these colloids, not removing this colloid, not removing the impurities from the colloids, that means the impurities may be destabilized and precipitate the colloidal solution. So that is called as what? Coagulation. Am I right? Coagulation. So here the impurities is mainly is electrolyte, because as per the impurities means mostly it may be an electrolyte. That electrolyte should be removed to increase the stabilization of colloids. Colloids must have some stable compound. Am I right? So we should be remove the electrolyte. Okay, remove the electrolyte. So anyhow, the purification of colloid solution can be done maybe by dialysis or electrodialysis or filtration method. Dialysis. Okay. About the dialysis already we maybe learn about the dialysis. Okay, we maybe learn. The biology students almost know about the dialysis. Okay, anyhow, we can discuss about the dialysis. Okay. Okay. Dialysis, the removing. Okay, removing electrolyte by means of a dialysis. Okay. Here, in 1861, T. Graham, one of the scientists about that, T. Graham, separate the electrolyte from colloid using a semi-permeable membrane. That we are saying in a dialyzer. Okay, dialyzer. Semi-permeable membrane. One of the membrane. That means semi-permeable membrane means mostly the olden days they are using an animal membrane also we are using. Animal membrane, that means bladder, and having some parchment paper, cellophane sheet. These are all used for the dialysis. Okay. Here what is the equipment here means this sheet having a small pores. What's the meaning of pores? Small pores means some small holes. Okay. Here, the small molecule or ions can be passed through the holes. Okay, or holes. Okay, that sheet having. Okay. Anyhow, the semi-permeable membrane. That means having a small pores having. Otherwise, you can be say small holes. Okay. Anyhow. A very fine pores. Okay, so by this pores a small molecule can be passed, not larger the colloidal particles. It cannot be passed the larger colloidal particles. Only a small minute molecules can be passed. Okay, anyhow, in this method the colloidal solution is taken in a big bag. Okay, a colloidal solution is taken maybe in a bag. Okay, I am just drawing that. Okay, imagine this is one of the bag. Okay, imagine this is one of the bag. Anyway, we are taking a small bag, and also it is suspended in a flowing water. That means we are adjusting one of the tank like that. Okay, one of the tank like that. Okay, here we are the colloidal solution. This is about the colloidal solution. Okay, this colloidal solution. Here having a number of electrolyte. Okay. This is about the electrolytes. Number of electrolytes. Here anyhow, maybe here having one holes there. Here water in. Okay, water in. Here we are using water out. Water out. Okay, this is full of water. This is a running water. Okay, running water. Okay, semi-permeable membrane. Colloidal solution. Electrolytes. This is the arrangement of the experiment. Okay, here the colloidal solution, due to the different methods for the preparation, maybe contain certain impurities. If they are not removed, it may be destabilized and precipitate the colloidal solution. This is called coagulation. Anyhow, the impurities are mainly about the electrolyte. Should be removed by increase the stabilization of colloids. Okay, one of the methods is about the dialysis. In 1861, T. Graham separated the electrolyte from a colloids using a semi-permeable membrane. In this method, the colloidal solution is taken in a bag, one of the bag, okay, am I right? One of the bag made up of semi-permeable membrane. One of the bag is made up of semi-permeable membrane. Is suspended into the flowing water. The electrolyte diffused throughout the membrane and they are carried away by water. Here, the electrolytes are diffused. Diffuse means, I told you that the semi-permeable membrane having a small, minute pores are having. Pores means small holes. That holes, all the electrolyte may be a positive or negative. This should be removed by means of the running water. Okay. Anyhow, the electrolyte diffuse out of the membrane, and they are carried away by this running water. This is about the dialysis. Okay. Can you understand about this concept? Try to understand the concept, and also near the textbook draw the diagram also fully for the understanding. Don't draw in the examination. Okay, only for just your understanding it. Okay. Next about that, we have to discuss about the second step is about the dialysis. Okay, second step is about that dialysis. That is about electrodialysis. electrodialysis. Here, the electrodialysis, just what is the purpose we are using the electrodialysis means? Electrodialysis just means by applying the electric field, okay, that is by applying the electric field, increase the speed of removing electrolytes from colloidal solution. The previous we discussed about that dialysis. The previous we discussed about dialysis. Sometimes it may be the speed may be decreasing. Am I right? Here, just we increase the speed for removing the electrolyte. So for that purpose, we are using the electrodialysis by applying some certain electrical current. Am I right? So the second one is about that electrodialysis. Electrodialysis. Listen, children. The last we discussed about the dialysis. This is just an ordinary method. Okay, the dialysis maybe the rate is maybe decreases like that. Maybe like that. Here, electrodialysis means the presence of an electric field increase the speed of removal of electrolyte from colloidal solution. Here, increase the speed of speed for removing the electrolyte from colloidal solution. The presence of electric field increase the speed of removing of electrolyte from colloidal solution. Here we must draw the diagram. Okay, first we are taking two electrode. That means just imagine this is one of the tank like that. Okay, this is one of the tank like that. Here we are two electrode. This may be a cathode. Okay, this may be a cathode, and one is about that anode. Okay, a cathode. Negative charge. Am I right? Anode. Positive charge. Cathode. Okay, anode. Here we are using about that one of the membrane here. This is one of the membrane. This is another membrane. Okay, here we can be say a cathode membrane and an anode membrane. Otherwise, we can be say cathode transfer. Cathode, otherwise called we can be say cation. Cation transfer membrane, anion transfer membrane. Cation transfer membrane, anion transfer membrane. Clear? Can you understand the concept? Okay. Here anyhow, here the colloidal solution of an electrolyte has impurities is placed between the two dialysis membrane. Okay. And also enclosed with two compartments filled with water. Yeah, this is maybe taken as one of the compartment. This is another compartment. In between this gap, we are taking what? Colloidal solution. And also filled with water. Clear? Can you understand the concept? Here we are taking the colloidal solution in between the two compartments. That means one is a cation transfer membrane and another is an anion transfer membrane. Here the colloidal solution containing an impurities electrolyte is placed between the two dialysis membrane enclosed with two compartments filled with water. When we are passing the current between where? Cathode and anode. Current we are passing. Clear? We are passing the current. So what will happen here? When current we pass the impurities pass into the water compartment to get removed periodically. That means, what is the purpose? Here we are passing the current means speed up this speed up the migration of ion to the opposite electrode. Once again, the colloidal solution having a number of an electrolyte may be positive, negative, positive, negative, positive, 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 like that. Negative, negative, negative. These are the electrolyte. Am I right? Here, positive electrolyte is attracted by the cathode, and about the negative electrolyte is attracted by the anode. Okay, that's the concept here. Okay, this is one of the concept. That is, here having cathode is a negative charge. Here cathode is attracted by the positive ions and the positive negative ions is attracted by the anode. Anyhow, here the electrolytes are removed periodically. Okay. Anyhow, this process is very fast. That's what we are saying that electrodialysis. Okay. This process is very fast than dialysis. Because the ordinary dialysis is the slow step process. That is one of the almost slow step process. Here the electrodialysis is the speed process, very speed process. Okay, this process is faster than dialysis as the rate of diffusion of electrolyte is increased by the applications of an electricity. Okay, here the rate of the diffusion of electrolyte is increased by the applications of electricity. Anyhow, this should be speed up the process. Okay, that we are using about that what? Electrodialysis. Can you understand this concept about that? Here, one of an very important point. Try to note there. Some of the electrodialysis is not meant for non-electrolyte impurities like sugar and urea. This is one of the important point. Those who are interested, you may be write on the textbook. It is not meant for non-electrolyte impurities like sugar and urea. Those who are interested, you can write this one. Anyhow, here we have one of the examples of here positive. Positive means we are giving. Just I am taking only for the sodium chloride. Sodium chloride, the formula of sodium chloride, all of you know that one NaCl. Suppose Na plus Cl minus, okay, Cl minus, Na plus Cl minus. So here the Na plus, here the sodium ion is attracted by the cathode electrode. Here. Here have a cathode electrode. What is the charge of cathode? This is a negative charge. That is all of you know that one. Okay. The negative charge is attracted by the positive ions, and also the positive electrodes is attracted by the negative ions. Okay. So it may be speed up. So sodium plus is attracted by the cathode, and the chloride ions is attracted by the anode. Okay, anyhow, this process is very fast as the rate of diffusion of electrolyte is increases by the applications of electricity. Okay, applications of electricity, very important about that. Next, anyhow, about the ultrafiltration. We can discuss the third one is about the ultrafiltration. what is about the filtration also we learned that one, about the filtration. Those who need, please write the filtration definition is there. Okay, those who are need, please write the definition for the filtration. The separation of salt particle. The separation of salt particle from an electrolyte by filtration through an ultrafilter. The separation of salt particle from electrolyte by filtration through an ultrafilter is called ultrafiltration. The page number 92, please check the page number 92. The first paragraph having about that ultrafiltration. Please mark it that one, ultrafiltration. Anyhow, the ultrafiltration is one of the very important questions for the 2-mark question. Okay. It's important, very important. Okay. Ultrafiltration. So, ordinary filtration, all of you know that one. Ordinary filtration is also one of the slow process. Ordinary filtration. So, why we are using the ultrafiltration? It also same like for speed up. Okay, anyhow, to speed up the reaction. Here, the colloidal particles are left on the ultrafilter in the form of slime. Okay, anyhow, this is one of the method. So, try to understand this concept. Then ultrafilter, just I am drawing that one, just on diagram, a small diagram like that. Okay, this is one of the modified ultrafiltration. Okay. Here we are applying gas pressure. Okay. Here salt plus electrolyte. This is salt particle. When we apply gas here, it will be falls down, okay? Falls. This is of the electrolyte. Okay. It can be water. Water and electrolyte. This is one of the diagram. Try to draw this diagram. Only for understanding, do not draw in examination, okay? Only just for the understanding. Here, the pores of ordinary filter paper permit the passage of colloidal solution. Sometimes, the ordinary filter paper, it has some pores also. It may be permit the passage of colloidal solution. But in the ultrafiltration, the membrane of made up of using colloidal or cellophane or whiskey. When the colloidal solution is filtered using a such filter, okay, one of the such filter means maybe the cellophane seal, okay, yeah. The colloidal particles are separated. Here having the filter, okay, here having the filter. it should be separate, the filter and the impurities are removed and washing. Okay. Here this process is quickened by the applications of pressure, because we are applying pressure here. Due to the high pressure, what happened? The electrolytes are easily removed from the salt particles. All the electrolytes are removed, easily washed or easily removed. That's a good name for the wash. Okay, that's a good name. And the impurities are removed as washing. Okay. Anyhow, the process is quickened by the applications of pressure. The separation of the salt particle from the electrolyte by filtration through an ultrafilter is called ultrafiltration. Okay. Here, one of the chemical we are using that one, colloid. That is one of the chemicals we are using here, colloid. That is cellophane or maybe whisking. Here, what is the colloid we are using? Is try to underline the line. The 4% solution of nitrocellulose. 4% solution of nitrocellulose in the mixture of alcohol and water. In the mixture of alcohol and water. Okay, this is about the colloid. The question may be asked about the one-word question. Colloid is 4% solution of nitrocellulose in a mixture of alcohol and water. Okay. Try to mark this question. Which are the question I gave for that. This one means purifications of colloids. That means one is about the dialysis. The second one is about the purifications of colloids. The third one is about that dialysis, that is electrodialysis. The third one is about that for the purifications of colloids by ultrafiltration. The first one is dialysis. Second one is an electrodialysis. The third one is an ultrafiltration. Clear? Next about what are the properties? What are the properties of colloids? Okay, what are the properties? We have more than 10 properties. What are the properties? We have more than 10 properties. Especially for the properties of kinetic properties are very important. We have optical property and also kinetic property. Here the optical and the kinetic properties are very, very important. Okay. Optical property means all of you know that one. Based on about that Tyndall effect. Okay, Tyndall effect. Okay, we have properties of colloid. What are the properties of colloids? Okay, it's an important question. This is one of the applications of colloids. Okay, properties of colloids. Okay. One color, second one is size. First one is the color, second one is the size, third one is the colloidal solution of are heterogeneous in nature. Colloidal solution of heterogeneous nature having two distinct phase. Fourth one, filterability. Fifth one, non-setting nature. Sixth one, concentration and density. Seventh one, divisibility. Eighth one, colligative properties. Ninth one, shape of colloidal particle. Okay, shape of colloidal particles. The 10th one is about the optical property. The 11th one is the kinetic. 11th one is the kinetic properties, and also about that. 12th one is the electrical property. Okay, here the optical property. Don't forget to learn about that Tyndall effect. All of you know about the Tyndall effect, and about the kinetic properties, about the Brownian motion, otherwise called the Brownian movement. Okay, Brownian motion, and otherwise called, we are saying about that Brownian movement. And about the electrical property means, again they are having three one. It's about the Helmholtz double layer, and about that electrophoresis, otherwise about the cataphoresis, and about that electro-osmosis. These are all very important properties about that, properties of colloids. Okay, anyhow, first one is about that, the color about that. All of you know that one, that the color of the sol is not always the same as the color of the substance in a bulk. Okay, here the color of the sol is not always the same as the color of the substance in the bulk. Here the example is about that. Bluish thing is given by the diluted milk is reflected light, and reddish thing is a transmitted light. Am I right? So color of the sol is generally depend upon the following factor. One of the very good 2-mark question. What are the factors that depend upon the color of the sol? 2-mark question. Please write their question. We write the question. What are the factors depends upon the color of the sol? One is methods of preparation. The second one is wavelength of source of light. The third one is size and shape of colloidal particles. The fourth one is whether the observer view the light, reflected light or transmitted light. These are the 4 factors depend upon the color of the sol. Okay. What are the 4 factors? Can you learn about the 4 factors? What are the 4 factors? One is about that methods of preparation. The second one, wavelength of source of light. The third one is about that size and shape of the colloidal particles. The fourth one is whether the observer view the reflected light or transmitted light. Okay, anyhow, Next about the size of the particles ranges from 1 mu to 1 mu diameter. Okay. Next about that. This about that one. We try to learn that one. Next about the third one is colloidal solution are heterogeneous in nature, having two different distinct phases. Here we learned the dialysis experiment. The experiment having two phases. What are the two phases? One is about that ultrafiltration and one is an centrifugage. Okay. That means during the dialysis. Okay. During the dialysis, maybe electrodialysis or any other dialysis, we get two phases. Two phases. This is maybe this is one of the, we are taking that one of the test tube, okay? Test tube. Here have two phases in the test tube. One is, we are in the colloidal solution. Two phases. One is about that ultrafiltration. The second one is about that the centrifugage. Okay, that is about that what? Centrifugage. Centrifugage. Okay. Wait, we have two phases. Anyhow, the centrifugage and ultrafiltration clearly show the heterogeneous nature in the recent times. The colloidal solutions are considered as borderline case. Okay, colloidal solutions are considered as what? The borderline case. Okay, the border. This is the borderline between ultrafiltration and centrifugage. Okay, centrifugage. Okay, ultrafiltration and centrifugage. Anyhow, next about the filterability. As the size of pores in ordinary filter paper are large, okay, the colloidal particles are easily passed through the ordinary filter paper. Okay, that means here the ordinary filter paper, all of you know that one, the ordinary filter paper. Okay, ordinary filter paper. Here having the number of pores, number of holes is there. Okay, that is a very minute holes is there. Small minute holes is there. That hole easily, the colloidal solution can be easily passed through that holes. So we are pasting in one of the colloidin. Okay, am I right? Colloidin. Already I told you about that colloidin. What is about the colloidin? Colloidin is a 4% solution of nitrocellulose in a mixture of alcohol and water. Am I right? So we are pasting the colloidin. So what happened? The size of the pores is reduced. Am I right? So the holes are almost, the size is reduced so that the colloidal solution never goes that one, but the electrolyte can be passed that hole. So am I right? So that is about the filterability. Next one, non-setting nature. Okay, what's the next one? Non-setting nature. The colloidal solutions are quite stable. They are not affected by gravity. Okay, they are not, underline the not, they are not affected by gravity. Next one is about the sixth one is concentration and density. When the colloidal solution is dilute, it is stable. When the volume of the medium is decreases, coagulation occurs. Okay, that's the meaning. When the colloidal solution is dilute, it is stable. When the volume of medium is decreased, coagulation occurs. Okay, generally, density of salt decreases with decrease in the concentration. Density of salt, okay, density of salt, that means colloidal solution. Density of salt decreases with decrease in the concentration. Next, about that diffusibility. Unlike true solution, colloids diffuse less readily through membrane because it is a true solution. Okay. The true solution, colloids diffuse less readily through membranes. Next, colligative property. I think that you may be learning in the 11th grade about the colligative properties. We have one lesson for about the colligative property. Okay. Colligative properties explains about the number of moles in a solution. Am I right? Number of moles. Am I right? Anyhow, they have some important properties about the colligative property. What are the colligative property? That's the elevation of boiling point, depression and freezing point, and osmotic pressure. Okay. Osmotic pressure, and here the measurement of osmotic pressure is used to find the molecular weight of colloidal particles. That's the important point. Measurement. Okay. The measurement of osmotic pressure is used to find the molecular weight of colloidal particles. Next, about the ninth one. It is very interesting to know the various shapes of colloidal particles. Okay, here I have some very good examples about that. Please all of you underline the one word. Okay, very important the one word. Page number 93. Some of the important shape. What are the important shape? About the colloidal particles, arsenic sulfide and ferric hydroxide. Okay. And about the tungstic acid salt. Okay. About this formula also you should be learn about the tungstic acid formula WO3O5. Okay, don't forget to learn this one word question about the shape of arsenic sulfide. What is the shape of arsenic sulfide? It's a spherical in shape. And ferric hydroxide, what is the color? Blue gold soil. Okay, blue gold soil, ferric hydroxide. And tungstic acid, about that, there also shape. What is the shape? Is rod shape. Ferric hydroxide shape is a disc or plate like. Okay. Anyhow, the optical property, kinetic properties, and Helmholtz double layer, electrophoresis and electroosmosis. These are a very important question. We can be discussed the next class. Okay. Anyhow, I am giving the today assignment about that. Please all of you try to learn this question. Electrodialysis. Okay. Today our assignment. Electrodialysis. Okay, please draw the electrodialysis the diagram and also the electrodialysis page number. Thank you. Okay, try to learn this question. Okay, thank you all of you. Thank you. Have a nice day.